Hey, geometry class AV2, this is unit 6, lesson 4, volume of a pyramid. In our previous lesson, we found that the volume of a prism is calculated by finding the area of the base times the height of the prism. So the volume of a pyramid is very similar. You're going to take the area of the base times the height of the pyramid, except you're going to multiply by 1/3. You can kind of visually see this. This is very informal, but if I were to take a prism like this and enclose a pyramid within that prism, right, connecting the vertices of the base of the pyramid with the exact same height. That wasn't very well done. Let's try that again. There we go. That's a little better. The volume of the pyramid ends up being 1/3 the volume of the prism. So this is going to be our formula that we're going to work with regards to the volume of the pyramid. Now, with that being said, the area of the base can be calculated in a number of different ways. It could be a triangle. It could be a trapezoid. It could be a regular polygon for that matter. So we have to have in the back of our mind all these different area formulas. Okay, so be prepared to calculate different areas determined by the base of the pyramid. All right, let's get into it. Okay, on this slide, guys, there is a link. This hasn't worked in the past. I don't know if it's an old link or whatever, but it shows a visual, and you can Google pouring test, right, or try to type in the website that you see at the top here. But again, it just confirms our formula of 1/3 the area of the base times the height. So let's get into a few examples of this. All right, so here I've got a square-based pyramid, and I'm going to make this a square-based pyramid because right now it's not necessarily by definition. I'm going to make that a square-based pyramid. And of course, I'm going to find the area of the base, which is a square. So the area of the base would be side times side, which is 6 times 6. And the height of the pyramid is, of course, this green length, which would be shortest distance from vertex to the base, which in this case would be 8. Now, in some cases, we might give you the slant height as well, all right, using that cursive L. But in this case, and in all cases for this situation, we would use that green length for the height. So don't be fooled by the slant height, or even at that, this edge length. The edge length is never useful in finding surface area or volume. So let's get into it. So the volume of this particular pyramid, correct myself, do some push-ups, would be 1/3 of 36, which is 6 times 6, times the height, which is 8. Well, 1/3 of 36 is 12. 12 times 8 ends up being 96 centimeters cubed. Cool. Let's look at another example. Okay, here yet again, I've got a base that I need to calculate the area of. Looks like it's a regular polygon with 6 sides. So that's a regular hexagon. So n equals 6. Looks like a equals 4, and it looks like s equals 5. So the area of this base, of course, is 1/2 ASN, which is 1/2 4 times 5 times 6. Okay, so the area of our base will equal, looks like 60 to me, 60 units squared. And I'm going to multiply that by the height and divide by 3. So our height, in this case, is given, and our height is 10. Okay, located up here in the introduction to the problem. So we're going to take 1/3 times the area of the base times the height. Area of the base was 60. Nice numbers here. We were very nice to you. And it looks like our volume comes out to be 1/3 of 600, which will, of course, be 200. Looks like centimeters to the 3rd power. All right, let's continue with another example. Okay, slightly different problem here. In multiple ways, this is a regular polygon, so the area of the base is going to be 1/2 apothem, side length, number of sides. Now, in this case, we are not given the apothem. So the apothem is what we are seeking. So the apothem is going to be unknown. However, the side length given, 10, and the number of sides also given from the visual, 5, tells us that the area of the base is going to be 1/2 of 50a, which will be 25 times the apothem. So I'm going to utilize that here in just a moment. The height of the prism, of course, is 8. So the height equals 8. So the volume, which is given, which is 458.67, is equal to 1/3 times the area of the base, which was 25a, times the height, which is 8. So my goal in all of this is to solve for lowercase a, the apothem. So in doing that, I'm going to use some inverse operations. First thing I'm going to do is I'm going to combine some like terms using multiplication. Actually, it's not combining like terms, it's just condensing. So I'm going to write this as, oops, let's do that, black, 458.67 is equal to 200a over 3. Okay, now to do some inverse operations to kind of strip everything away from a and have a all alone, I am going to multiply both sides by 3 and then divide by 200 in a moment. But multiplying both sides by 3 gives me, on the left side, 1,376. On the right side, I get 200 times a. The next inverse operation I will do is I'll divide both sides by 200, and a ends up equaling 6.88 centimeters. That's how you find a missing length, in this case the apothem, given the volume and all the other components of the base. All right, let's do one more example. Okay, this example says find the height of a triangular pyramid with volume 150 cubic centimeters, base length 20, and base height 5. So sometimes it helps to sketch this. So I'm going to sketch the base of the pyramid. Okay, so here's the base of my pyramid. This, for example, could be a right angle. Okay, the base of the base is 20 centimeters. The height of the base is 5 centimeters, and then with a little bit of it's kind of hard to tell there, but perception-wise, if this space was my base area, and of course my height of my pyramid, isn't necessarily easy to see here, but the vertical height, right, perpendicular to the base, we are given is the unknown. Okay, so we know the volume. The volume is 150 cubic centimeters. Do we know the area of the base? Why, yes, we do. All right, I'm going to calculate the area of the base, which is the yellow space here, which would be 1/2, since it's a triangle, base times height, which would be 20 times 5. So 1/2 of 20 times 5 ends up being 50. So the area of the base is 50. And the height, I'm going to actually write in red here, is unknown. Let's solve. So just like we did in the previous problem, I'm going to compress this slightly. Right, this is 50h over 3. And using inverse operations, I'm going to multiply both sides by 3. That gives me 450 equals 50h. This should be a nice problem. Comes out to be nice and clean. I'm going to divide both sides by 50. And it looks like h comes out to be 9 centimeters. All right, guys, there's your lesson on volume of pyramids. See you in the next video.